Well, welcome back everyone to another online video lesson. In this lesson, I'm going to go through some questions that involve various construction techniques that were explored in the lecture on constructions. And you should have all watched that lecture, so you should all know what I'm talking about. Here you will see me showing you how to use some mathematical instruments physically. What you will need for this lesson today is a pair of compasses. So something like this, which is used to draw arcs and circles, a ruler for measuring lengths of straight lines, and of course a protractor for measuring the size of angles. Something like this will be sufficient for today. Anyways, let's get started on our work for today. So this is session 5 of the online collaboration session. And question 1 says construct angle bisectors of each angle AOB below. So if you remember from the lecture, to cut an angle in half, so bisect means to cut the angle in half, we'll need a pair of compasses. So opening up my compass and putting the pin end on the angle O, what I want to do is I want to just draw an arc across this part of the angle. Now you can make it as big or as small as you want. I want to go through both arms of the angle. Now what you've created is two intersection points. One up here and one down here. Now from these 2 points, I want to draw an arc. And I want these arcs that I draw from those 2 points to intersect. Now you can open it or close it as much as you want. I might open it a little bit more so you can see what's happening. So I draw an arc up here where I think the angle is going to be in half when they intersect. So we know if we draw a line out, the halfway point is somewhere here. So I want the arc to go to that point. Now keeping the same length without changing the spacing of your compass, I want to do the same thing on the other side. So on this intersection point, I want to draw another arc. That's a little bit tricky because sometimes the compass moves. So just be careful to try and not make the compass arms expand or contract. You want to keep them exactly the same. Now that point where these two arcs intersect is the point I want to join from the apex, from that vertex there. That line from this point to this point is the angle bisector. So this line cuts this angle in half. Now if you've done it accurately, this angle down here should equal this angle up here. Now you can verify this by measuring using a protractor. I'm just going to quickly show you that. So to use a protractor to measure the angle. Now the question didn't ask that, but I'll just show you how to use a protractor. I want to put this, you can see this little plus in the middle. I want to align that with that corner point here. And I want to match this straight line, this 0-degree line, with this arm OB. So they're on top of each other. Now I can see the angle is approximately 39. Now I don't have more markings on the inside, but some of your protractors will have more markings so you can get a more accurate measure. So it's approximately 39. And I'm assuming that this will be the same, this angle AO, we call it C, maybe. And AOC is the same as angle BOC. So So measuring this one, I also get approximately 39 as well, 38. They're both the same. Now B, that's an interesting one. It wants us to construct an angle bisector of angle AOB, but it didn't specify which side. We can bisect this angle in two directions. We can do the same technique as we did in part A. So draw an arc here, and from these two arcs, so from these two intersection points, draw another arc down here, and join it through. That will cut the angle AOB in half. Now you can also do it the other way around. It'll be exactly the same. So usually we want to cut the smaller angle in half, but I'll show you how to do it with the other way as well to show you that also works. So let's just draw an arc around, so make it maybe a little bit smaller. Whoops. So you got to make sure it doesn't slip. Okay. Now, so these are my two intersection points. Could have done it the other way. As you can see, the entire circle makes no difference. So make it a little bit bigger. Okay. Might draw an arc up here. And from the other side, as I said, from these two intersection points, that's where the pin sits, and we draw our arcs from there. And that's my intersection point that I want to join with that corner O. Now you could have done it the other side, here and here. You would have got the same result. So it wouldn't make any difference. So either direction is fine. So you wouldn't get it wrong in the test, whichever way you go, as long as you follow the correct steps. I'm going to cut that through, and that will cut angle AOB in half. Okay. Question 2. Construct an angle of 60 degrees at the endpoint A and an angle of 90 degrees at endpoint X on the interval AX below. So at this point A, I want to draw a 60 degree angle. And at this point X, I want to draw a 90 degree angle. Now let's go to the 60 degree angle first. Now hopefully you remember how to do this from the lecture. Remember, drawing a 60 degree angle is based on the property of an equilateral triangle. So starting from point A, I'll just open up my compass arms to a certain length. I can choose whatever length I want. Might want it a little bit smaller. Now we didn't want to do that because it slipped. Might put some more pressure on the pin arm. So I'll draw an arc. Now keeping the same length, draw another arc to intersect that original arc I drew. Now, as I said in the lecture, if we join these 3 points, this one, and this one, I'll make an equilateral triangle because all these lengths were the same. As my compass never changed its arm lengths. So therefore, if we join all 3 of those sides, we'd get an equilateral triangle. 1, 2, 3. And we know with an equilateral triangle, all angles are 60 degrees. So therefore, I know straight away, if I join A and that point I just drew, I'm going to get a 60 degree angle. Therefore, this one's 60 degrees. Now the 90 degrees is a little bit more tricky. Now I just quickly measure that just to make sure. Yep, indeed, it's about approximately 60.